Hello, thank you for joining RasPipKr tutorials. I'm Martin Parker, and in this tutorial I'm going to talk to you about threading. It's part of your standard library, so you do not need to install it. To import it, you just simply write import threading, and there you go. There is a help, so you can get all the documentation for the threading library. As you can see there is 963 lines, so I'm not going to bring that on screen for you now, but you can have a read through that. But to look at the functions, if I do the directory of the threading library, there is a list of all the functions. Now we're going to use this one here called thread in this example. So let's get going. I'm also going to import the time library because I'm going to be using that. I'm going to create a function called timer, and it's going to take an argument of t, and all it's going to do is going to print to screen starting. I'm going to put a placeholder in there for that timer dot format, so it puts it in. What we're going to put in is threading dot current underscore thread, and this is a function. If you look there, you'll see it is this one here. So I need to put the parentheses brackets dot name, and there we go. And it's going to time dot sleep for the length of t, whatever the argument is that we put into it. And basically I'm going to put the same line in again here. I'm going to change that word to finished. So there we go, there's our function for our timer. And if I call the function timer 2 seconds, and there we go, it's finished. 2 seconds later, obviously. So it's starting, it put the main thread as the placeholder for the current thread that we are running, because we imported it. So this bit of program is called the main thread, but when we get into calling other threads, they will have their own name, like thread 1, thread 2, thread 3, etc. So let's just create a quick for loop for I in range. We'll do 5. Let's create 5 instances of the timer. So I can't use t because I've got t in my timer function. So I'm going to call the instance a is equal to threading dot with capital T, just like the function is up here. And to get it to run that function, you need to set it to a target. So target is equal to timer, and then because if we're not using any arguments, we would just close it off like so. But as we are using arguments in our function, we need to put a comma and then args for arguments, and in here we have to use a tuple. So let's put in the I that we are running through as a loop, and you have to put it in as a tuple, so like so. So that's set, and then a dot start, and that is it, and it's going to run and start running. If I don't put a time dot sleep in here, it's going to run all this 5 loops straight away, and these will run in the background, but it's going to try and do all these 5 in one line. and you'll see here, see how this is all just jumbled up together. So it's finished now. So starting timer, there's the first instance of the function timer being started, and there's the second one, the third one, there's the fourth one, and there's the fifth one. And then a second apart, these were finishing and printing to screen. There is another way that you can do it. If I just click on the for loop and press enter, it drops it all down here. And if I add the line a dot join and then press enter, it will do them in the actual order. But notice how it's, because these threads were used, there we go, it's all finished now. Because we started our threading library up here, the first thread was brought into it here because we're still using the same threading library in this Python shell. Although the first 5 threads were used, it's not going to bring them up again. It will do the following 5 threads. So it will do them in an order, and it will keep going into the hundreds, etc. Every time you create one. So that is a way that you can use threading. Even though the thread is finished, it will go on to the next number. So like we did earlier with the threading, we just use the .start method for the thread, and it started them all at the same time, and then they finished separately after their timers. But when we use the .join, it ran the first one with its time, which will have been 0, and then it's run the next one with the second gap, and then the next one with a 2-second gap, and then the next one with a 3-second gap in between, and then the last one with a 4-second gap. But it's done them all in an actual order. So that is using the start and the joins difference. So I'm just going to show you another example. I'm just going to get rid of this so I can move to the top of the actual window. And you'll see that I'm working with the threading, well, the thread 1 again, because I've got a new window working. So I need to import threading. I'm going to import the time module. I'm going to create a variable called A, and it's going to be an empty list. And what we're going to do is we're going to add jobs into this A list. So we're going to append into that list. And I'm going to create a function called job. It's going to take no arguments, and it's going to use a global, so we can call this out of this function, and this will be a variable called jobs, and jobs will start with the initial value of 0. I'm going to put this into a while loop. So while jobs is less than or equal to 5, do something. Obviously I'm going to increment jobs, otherwise it might as well have just been a while true loop, because it will never get to stop. So we're going to check, so if the length of how many entries are in the list of A is not equal to 0, so while there's something in there basically, it's going to print starting should put starting job, no, awaiting jobs. So it's going to print the amount of jobs that we have, and then we're going to print the feedback from that job, which will be basically what we append into it. So it's going to print out the first element of the list, and that's pretty much it. But because we've done that job by printing it, yeah, leave it as feedback. We're going to a.pop the first index, so it's going to print it and then it's going to get rid of it, so it's completing that job effectively. And we need to increment the number of jobs, so jobs plus equals 1, and that means that job is being completed. And then when it's eventually got to 5 jobs, it will drop out this while loop. But we're going to put a time.sleep in here for 30 seconds, so it gives me plenty of time to append jobs into it. And after because we're back over here, we are out of this while loop, so when we've done 5 jobs adding in, it will print all the jobs are done. Okay, so that is our function. And what we need to do is, if I run this, it will just sit there in the background, and I won't get my cursor back. So that I don't want to do. So if I create an actual threading instance, so if I call t is equal to threading dot thread with a capital T, we're going to target the function of job. There's no arguments, so we can just put the parentheses at closing bracket. That's done. And then tell it to t dot start. That function of job is now running in the background, and I can do whatever I want in the code. So if this was part of a script, I can do stuff now. And because I called this variable as a global, if I call the jobs, it's showing still as 0 because we haven't passed any jobs yet. It's not incremented. And if we get a, it's still an empty list. But if we a.append into the a list, then we'll put hello world. Everybody likes the hello world. And then we put a.append a number. There is 2 jobs in the a, and there we go. It started because it was part of the sleep time. It started doing the job. Oops, that's because I had it clicked on it. I highlighted it, that's why it brought it up down here. So it's done that hello world, the first job, and if I call a now, there's just that number 1 left in there. And then after a few seconds, there we go. So that function has been still running, and it's now done that other job, and it has printed out that number 1. And now if I call a, which is empty, but because I have appended into the A list twice, and I have a jobs added incremented by 1. So if I call the variable jobs, it has 2 jobs being passed. The only downside is I don't know whereabouts it is in this time.sleep, but let's a.append again. Feedback. Please like and share. Should have put a comma. Like, share, and subscribe. That's a cheeky little add to the video, isn't it? Now that's in there, let's a.append again, the number 55. So if I call A, there's 2 jobs in there, and eventually it's going to do one of them. There we go. So it's got rid of, this is now done that first job. If I call A now, it's got that last job of the number 55. If I a.append now, I can put a float number in there. Call A, it's 2 jobs. How many jobs have we done so far? 3. So after a few seconds, there we go. So it's done that one. So there's only 1 job left in there, and the amount of jobs we've done is 4. So as soon as after a few seconds, it will do this last job, and then it should, let's just bring it back up, print out that line there. And it's not printed out the thing because we should have broke out of the still in the loop, isn't it? If I put another job in, just 1 job in, it shouldn't run that bit of code because I had it set to 5. Because it's doing the 30 seconds. A's still got some in there, which is now done, and then after 30 seconds it should say, well, print to screen, all the jobs are done, because now the jobs number is 6. It should be about 30 seconds from when there, all the jobs are done. So there you go, that is a way that you can get use the threading library to have jobs running in the background. Now the reason why I've done this video today is because I'm going to have jobs, well, not really so much jobs, but a list of events triggered in my home heating and security control. On my last video, if you are following along the playlist for that playlist, I got external sensors on my house, and when it's triggered, it gets my Google Home Minis to voice announce the area that's been triggered. But the trouble is, if you get it to try and do all the instances, say if you had, because I have front, side and rear, if all them triggered together, it won't voice announce the first, the second, but it'll do the last one, because it's it takes a split second for it to actually tell the Googles to do it. So this video, by creating these jobs that I've been doing here, I can separate out and it will go through the actual order of the triggers in respect of the external sensors. So that is it for this threading video. Thank you. Please like, share and subscribe. Sneak that one in there. Yeah, thank you for watching, and I will catch you in the next one.